Hello, good afternoon, and welcome to our lesson of today. Okay, today we are going to be looking at solar radiation as a continuation of our last lesson, solar radiation. Without taking much of our time, we shall go into the objectives of our lesson. Solar radiation. Under this lesson, it is expected that by the end, you should be able to understand what solar radiation is. Secondly, you should identify the sources and nature, the source and nature of solar radiation. Thirdly, you should be able to explain how solar energy is transmitted. You should be able to describe the depletion of solar energy in the atmosphere, and you should be able to explain energy transfer processes from the Earth's surface to the atmosphere. Okay, with respect to our objectives, the very first thing we have to look at here is solar radiation. What is it all about? Solar radiation is the energy that is emitted by the sun in the form of electromagnetic waves. Yes, every day in, day out, we have solar radiation. We observe solar radiation. We work under solar radiation. In fact, we do everything. Earth's processes that take place on daily basis are thanks to the energy provided by solar radiation. So what is solar radiation? We say it is the energy that is emitted by the sun onto the Earth's surface in the form of electromagnetic waves. Electromagnetic radiation, you should understand, is a form of energy that travels in waves. Yes, any form of energy that travels in waves is an electromagnetic radiation, and the solar energy is a typical example. The different types of electromagnetic radiation are distinguished by their wavelength. There are different types of electromagnetic radiation that are found within our atmosphere, and their differences lie in their wavelengths, and they include visible light, infrared radiation, and ultraviolet radiation. Now, let's look at source and nature of solar radiation. Source. Where does solar energy come from? Where does solar radiation come from? Of course, the sun is the only source of solar radiation. Yes, the sun is the only source of solar radiation. That is where solar radiation comes from. And radiate means this energy travels from the sun. It is sent out from the sun. The sun is a giant ball of plasma that is constantly fusing hydrogen or burning hydrogen atoms together to form helium atoms. This process releases a tremendous amount of energy, which is emitted as solar radiation. So, like we saw in Form 3, the sun, in Form 1 and 3, the sun is one of the bodies that constitute our solar system, and day in, day out, it is continuously burning, to produce burning hydrogen atoms to produce helium atoms, and this process generates huge amounts of heat that is radiated onto the Earth's surface as solar radiation. Let's proceed. Let's look at the nature types of solar radiation. Solar radiation is composed of a wide range of wavelengths, like we saw earlier on. There are three major kinds of categories of wavelength here, and under that we shall look at visible light, the infrared radiation, and then the ultraviolet radiation. What do we mean by visible light? Visible light is a type of solar radiation that we see. Yes, that we see. For example, when it is day dawn, when the sun rises, you are able to see across your environment thanks to visible light. Then we have infrared radiation. This type of solar radiation that we cannot see. It It is responsible for the heat that we feel from the sun. So we only feel it. So infrared radiation is only perceived. Yes, the sensible heat that we feel, that is what is known as the infrared radiation from the sun. And then we have the ultraviolet radiation, which is a type of solar radiation that we cannot see. It is responsible for the sunburns and cancer. Yes, here we have said that visible light is what we see. It helps us to see across, see objects, and so on. Then for the infrared, we only feel, at times you don't even see the sun burning per se, the sun rays radiating or coming from the sky, but you feel the fact that there is heat, there is solar energy around you. That is the infrared we only perceive. Then for the ultraviolet radiation, this one we do not see as well, but it has a major role to play in our environment because its effects are far-reaching. It is responsible for the sunburns and for the skin cancers that are usually caused by exposure to sunlight, excessive sunlight. Now, let's look at this. So, a combination of the different types of wavelengths that we have from solar radiation, that's the visible, the infrared, and the ultraviolet, gives rise to a spectrum known as the electromagnetic spectrum. So the electromagnetic spectrum is represented here by this image we have on our screen, and I'm going to break it down as follows. You see from the left hand corner, as we move towards the right, the wavelength becomes shorter and shorter and shorter. Now the longest wavelength here we have as microwaves. These microwaves, what are their uses? Microwaves are used in apparatus like radio and the microwave that we use at home in cooking. We have the infrared that we mentioned earlier on. The infrared, we said, transmits heat from sun. Then we have the visible light, which makes things visible to us. You are able to see across, you are able to see and know that this is a plant, this is a tree, this is an animal, thanks to the visible light of the electromagnetic spectrum. And this visible light is made up of different colors. It's called the color spectrum. Again, within the electromagnetic spectrum, we have the color spectrum, and you can name the different colors. Then we have the ultraviolet that we have mentioned, absorbed by the skin, used in fluorescent tubes. Okay, the ultraviolet we do not see as well. We only feel it. Now, there are different instruments that can help us see sources that emit ultraviolet rays, but like specialized eyeglasses, as you will see on the image on the screen. Then we also have the X-rays. Okay, so as the wavelengths get shorter, we have the X-rays, and the X-ray here is used in the medical field, of course, to see through our bodies. So the X-ray here is very important in the medical domain. And then lastly, we have the gamma rays. Let's move on to the next slide. And the next slide here, we're going to be talking about how solar energy is transmitted. How solar energy is transmitted? Yes, solar energy is transmitted through space by electromagnetic radiation. We have heard that. We have talked about electromagnetism before. We have looked at the electromagnetic spectrum. So that is how solar energy is being transmitted from its source, which is the sun itself. Okay, back in form 4 or form 3, we must have heard about the speed of light, which is about 300,000 kilometers per second. Very fast, very fast. So that is how energy is transmitted from its source onto the earth's surface through the electromagnetic radiation, through that spectrum at the speed of light, which remains same for all the different types that we've seen. Now looking at the depletion of solar energy. Depletion What do we understand by depletion? Excuse me. Depletion here simply means that something is deteriorating, something is diminishing, something is being uh, destroyed. You know, something is being affected negatively from its original state. Okay, this is to tell us that as solar energy is being produced, as it passes through the atmosphere onto the Earth's surface, it depletes. The quantity, the amount of solar radiation that is produced from the sun is not the same amount that finally reaches the Earth's surface. Okay, looking at the diagram on our screen, we see that 100% of solar energy radiates from the sun. But as it goes through the atmosphere, about 6% is reflected back into space or into the atmosphere, while about 20% is reflected by clouds. Then we also have about 19% which is absorbed by the atmosphere and clouds. Then 51% absorbed at the surface of the earth. Then when it finally reaches the earth, not all actually is absorbed by the earth, because some is reflected back into the atmosphere by the surface of the earth, which is about 4%. So you see that at the end of the day we finally have about 51% reaching the earth's surface, and out of that 51, 4% again is sent back onto the atmosphere, and so we end up having just about 46%, 46 to 47% of solar radiation finally being used on the Earth's surface by the dry land itself and the water bodies. Now, these are the different ways through which solar energy or solar radiation depletes. We have looked at the fact that as it goes from the source onto the Earth's surface, it is being redistributed. Some goes back into the atmosphere, some absorb, and some finally reaches the surface. Okay, these are the processes that are responsible for solar energy depletion or solar radiation depletion. We have absorption here, which is the process that solar radiation is absorbed by gases and particles in the atmosphere. In our homes, we have sponges that we use in bathing, we use in washing utensils. When you send a sponge into water, it absorbs water, that's it retains, it soaks water. That is the same thing that happens with solar radiation. As it passes through the atmosphere, some of it is absorbed by gases, yes, and other particles that are found within the atmosphere. Now the most important gases that absorb solar radiation are water vapor, carbon dioxide, and the ozone gas. Remember, during our last lesson we talked about some gases that are responsible for the absorption of heat, and these are the gases that help keep our atmosphere warm. So the main gases that absorb heat in the atmosphere are water vapor and carbon dioxide. Then the ozone gas is also responsible for the absorption of solar radiation, especially the ultraviolet properties of the solar radiation. Now we've said particles also do absorb. These particles include dust particles, smoke, and cloud particles. Okay, let's move on. We move on to the second process through which solar radiation is depleted, and this process is known as scattering. Scattering. What do you understand by scattering? Scattering, when solar radiation reaches the atmosphere, as it goes through the atmosphere, part of it is scattered, dispersed back into the atmosphere. So the most important gases that scatter solar radiation are air molecules. The air molecules, of course, meaning whether it is hydrogen, nitrogen, oxygen, carbon dioxide, water vapor, or what, they are molecules. Generally, all the gases are responsible for scattering of solar radiation. And then particles that do scatter also include dust, smoke, and cloud. We also have ash, which is not mentioned here. Ash is another factor of scattering, and ash comes mostly from volcanic eruptions into the atmosphere. Then we proceed by looking at reflection. This is another major way through which solar radiation is depleted. We have heard that when part of it goes through the atmosphere, it is reflected by clouds. It is also reflected by particles, of course, and when much of it reaches the Earth's surface, again, it is being reflected. Reflection is the process by which solar radiation is bounced back into space by clouds and other reflective substances. Okay, and if we should look at an example here, a common example, when it is shining and you take a mirror and you hold it against the sun ray, you discover that it reflects sunlight back into the atmosphere. Or if you hold it, it depends on your angle, it will receive and then sometimes reflect it back onto your face, and you really get some heat from that process. That is to tell you that as solar radiation hits a surface, especially surfaces that are good at reflecting, much of that energy is sent back into the atmosphere. Let's look at now the energy transfer processes from the Earth's surface to the atmosphere. Okay, we have heard that solar radiation leaves the sun, goes through the atmosphere onto the surface. Now, how does the energy that reaches the Earth's surface, finally find itself back into the atmosphere? We are told here that energy is transferred from the Earth's surface to the atmosphere by terrestrial radiation, convection, latent heat transfer, and conduction. Okay, terrestrial radiation. Talking about terrestrial radiation, what do we mean by this? Terrestrial radiation is also known as ground radiation. Of course, terrestrial means ground, the surface of the earth. So the surface of the earth is good at reflecting and radiating heat back into the atmosphere when it finally reaches the earth's surface, and this is usually referred to as the ground radiation. So terrestrial radiation is the emission of long wave infrared radiation from the earth's surface. You see, so it is an infrared kind of radiation that we do not see. Of course, you will not tell me that you have once seen the earth sending out beams of light. No, it doesn't occur that way. You only feel that heat escaping from the surface of the earth back into the atmosphere. Sometimes, to really make an appraisal of terrestrial radiation, consider a very hot day, and all of a sudden it rains, it pours on a tarred surface, on a paved surface, and immediately thereafter you walk outside. You will notice that you find some vapor rising from such surfaces. Of course, that is a form of ground radiation. And then you see the vapor, which is water vapor, of course, you also feel the heat that is going through passing through your legs and going back into the atmosphere, which is now the infrared properties of that heat that we cannot see. Yes, that is a way by which ground gives out radiation when it reaches the earth's surface. Another example, typical example, you bear with me here, is the fact that sometimes you pass through beside a wall in the evening, a wall that has been exposed to solar radiation during the day. Later in the evening, say at about 5:30 p.m., 6 p.m., when the sun has set, you pass around that wall and you feel some heat. You feel as if there is fire at the other side of the wall. That is not fire. It is not magic as well. It is the fact that that wall is sending back radiation. It is sending back the energy that it absorbed during the day into the atmosphere. or onto the environment, which will further go back into the atmosphere. So those are all illustrations of terrestrial radiation. Okay, we also have convection. Convection is the transfer of heat through the movement of air. So as air is heated, as it moves across the earth's surface, it tends to heat up the surrounding. As it rises back into the atmosphere, it tends to heat up the upper layer of the atmosphere, or the yes, the upper layer of the atmosphere, but not as far as about 10 kilometers, because by the time it reaches that section, then condensation will take place, because cooling also had taken place. All right, sorry, let's proceed. Now, another way through which energy or heat is transferred from the earth's surface onto the atmosphere is through latent heat transfer. Latent heat transfer is a transfer of heat that occurs when water evaporation or water evaporates, I beg your pardon, from the earth's surface. When water evaporates, it absorbs heat from the surrounding air. Now, latent heat of vaporization. Good. When evaporation takes place, of course, water is heated and then evaporation takes place, where water returns back into the atmosphere in the form of water vapor. Now, as these water molecules in the vapor rise into the atmosphere, they rise with heat, and as they get into the atmosphere, they tend to, as they are rising, they tend to give out their heat. They tend to give out this heat back onto their surrounding column. The heat is lost into that column, and that is what we call latent heat transfer. Latent heat transfer. So this heat is released back to the atmosphere when the water vapor condenses and forms clouds. Yeah, so it loses heat as it rises, and when it finally reaches the atmosphere, the last content of that heat is given off before condensation and the formation of clouds occurs. Okay, now talking about conduction. Earlier mentioned, I said conduction is a process by which heat is transferred from the Earth's surface onto the atmosphere or into the atmosphere through direct contact. Direct contact of what? Of air molecules, of course. Now, how does this occur? The Earth, which is already heated, causes the air molecules that get in contact with the Earth's surface to be heated as well. When they get heated, as they rise or as they float around, they get in contact with other air molecules, and that is how heat is being transferred from the surface of the earth into the atmosphere through conduction. Okay, dear students, dear learners, dear viewers, with this we have come to the end of this lesson, in which we have looked at solar radiation. We have looked at what solar radiation is all about. We also identified the source where solar radiation comes from, which is the sun, we said, and then the nature of solar radiation. And under that, we saw how solar radiation exists or can be categorized based on wavelength. And under that, we saw three major kinds which are important to us. We talked about visible light, and that is what helps us to see on daily basis. We also have the infrared. The infrared we do not see, I beg your pardon, but we feel it. We feel it. That is what gives us the sensible heat that we feel on daily basis. When you say it is hot, the atmosphere is hot, or the temperature is high, and you start sweating, it is not the visible light that is affecting you. It is the infrared properties of the sunlight that makes you feel that heat. Then where we also looked at the ultraviolet, which are the The dangerous properties of the sun, which we do not feel as well, but we only see the impact on our bodies, especially when we are faced with skin burns or sunburns and skin cancer. We also talked about how solar radiation or solar energy is transmitted. We said solar radiation is transmitted from the sun, of course. It is produced in the sun, and from the sun it is radiated as electromagnetic waves onto or through the atmosphere onto the earth's surface. Now, by the time it reaches the earth's surface, it has passed through the atmosphere, wherein it is much of it is scattered back into the atmosphere, much of it is reflected back into the atmosphere, and much of it as well is absorbed by the atmosphere, by the properties, constituents of the atmosphere, like water vapor, like clouds, like particles. And then we also saw the fact that when part of this energy reaches the earth's surface, which is just about 51%, another proportion is reflected immediately by the earth's surface, by water bodies, by plants, back into the atmosphere. Now, you see the earth's surface in general ends up receiving just about 47%, 48% of solar radiation. Okay, now how we saw the different processes that leads to this depletion. Of course, we have mentioned scattering, we have mentioned reflection, we have mentioned absorption. Then we also looked at the processes through which the earth's surface in turn sends out energy or the radiation it received back into the atmosphere, because it is a circle. It is a circle, and it is thanks to this circle that the energy, the earth's atmosphere system keeps on thriving, keeps on changing or evolving day in, day out. So the earth's surface or the sun produces and radiates energy onto the earth's surface. The earth's surface receives the energy and sends out some of the energy, much of the energy of course, back into the atmosphere. Unfortunately, we cannot see it, so it is in an infrared. They are infrared waves that are sent back into the atmosphere, and they are long wave radiations sent back into the atmosphere that we cannot see, we only feel. And it gave good illustrations talking about a wall that absorbs in the day and gives out heat at night. I equally talked about during a hot day, and then we have some showers. Yes, after those showers, when you step out and walk on a tarred surface, you realize that water is being evaporated into the atmosphere, and besides that, there is heat. You feel heat burning, or let me say burning in quotes. You feel the heat that affects your legs as you walk along that path, or as you walk over that paved surface. Excuse me. Yeah, so under that we saw latent heat of uh, latent heat transfer. We looked at convection. We also looked at conduction, and that is where we came to the end of the lesson for today and the end of this interesting video. Ladies and gentlemen, dear viewers, we draw the curtains here, and I would like that during our next lesson we should be more attentive. I promise you it's going to be more interesting during the next meeting, during the next video. All right, until then, we call it a day. Ciao.